Our next type of application problem involving a quadratic model will be those of flying object problems, such as if you throw a baseball up in the air, how long will it take to come back to the earth? Or if you throw a baseball up in the air, how long or at what times will it be at a height of, let's say, 8 feet? Well, that would happen once on the way up and once on the way down. That's why these are quadratic. In Table 1.1, it outlines the formula we are to use for these types of problems. The height, the vertical position, the height, is equal to -1/2 gt squared, where the g is the gravitational constant determined by if you're working in feet, or you'll use the 9.8 meters per square second if you're working in meters. So -1/2 g times t squared plus v naught is how you read that, v sub 0. V naught means the initial velocity times t plus s naught. S naught is called the initial height. They call it the initial vertical position, but I like to call it height, where s is the vertical position or the height of the object at time t. On our notes, we have an example that says a child tosses a ball straight upward from a height of 1.5 feet with an initial velocity of 48 feet per second. So the initial height is 1.5 feet. The initial velocity is 48 feet per second. Since we're dealing with feet, we're going to use the 32 as our gravitational constant that will go in here. And we'll plug the rest of the things in. And once we plug them in and simplify just a little bit by multiplying -1/2 times 32, here in the purple box we have a mathematical model that will represent the height of the object at time t. For our example, it states, in a classic Seinfeld episode, Jerry tosses a loaf of bread, a marble rye, straight upward to his friend George, who is leaning out of a third-story window. On part A, it says if the loaf of bread leaves Jerry's hand at a height of 1 meter, with an initial velocity of 18 meters per second, write an equation for the vertical position, that's the S, of the bread, and that's going to be measured in meters, t seconds after release, after the bread leaves his hand. Then we'll tackle part B. Now, on part A, notice the tip here says that we're going to use the gravitational constant number of 9.8 because everything in our problem is being measured in meters. So, our formula on the previous page says that the height is going to be equal to -1/2 times that gravitational constant of 9.8 times t squared plus an initial velocity of 18 meters per second times t plus the initial height of 1. Now when we go to clean this up, -1/2 times 9.8 is -4.9. So we have -4.9 times t squared plus 18t plus 1. Now from this model, this equation we have set up, we're going to be able to make all kinds of predictions about this whole scenario where he's throwing this marble rye up into the air up to his friend that's leaning out of a third-story window. So on part B, it says, how long will it take the bread to reach George if he catches the bread on the way up at a height of 16 meters, round to the nearest tenth of a second? So we want to know at what time or times, that's what it means by how long will it take, how many seconds will it take for the bread to reach a height of 16 meters. So we're going to be putting in 16 in our model and solving for the unknown times. So now the equation looks like 16 equals negative 4.9 t squared plus 18t plus 1. We notice we have the t squared term, the quadratic, so our first step is to get everything on one side equals 0, and we'll accomplish that by subtracting 16 from both sides. And 1 minus 16 is a negative 15. Now at this point, I don't see how that factors very easily, and so I'm going to be putting these values in my quadratic formula. Negative 4.9 will be the A value, the B will be positive 18, and the C will be negative 15. So, solving for t, that's my variable, that's my unknown, I take negative b, so in this case that will be negative 18 plus or minus the square root of 18 squared is 324 minus 4 times a times c. The a value is negative 4.9. The c value is negative 15. And then all of this is over 2 times the a value of negative 4.9. Now it's a matter of simplifying this a little bit and cleaning it up. So my solutions for t are going to look like negative 18 plus or minus the square root of something all over negative 9.8 is what 2 times negative 4.9 is.